Welcome. Welcome to Total Chaos. Let's give it up for our performers. Charlashka Nipeve, Rio Crew, and International Dance 360. That's how you start a conference, right? So are you guys ready for chaos? How many, just by a quick show of hands, how many of you were here last year for our first event? You couldn't get enough chaos. I love it. Well, for those of you that are returning, welcome. For those of you that it's your first time, welcome. We've brought you more chaos than ever before, and we're excited about it. This year, hopefully you had a chance for a full day of master classes yesterday. And for the next 2 days, we have over 70 speakers from around the world for some amazing sessions. To make your experience at Total Chaos even better, make sure you download the app if you haven't already. It's your window into the entire conference. You'll be able to schedule your talks, keep in touch with your friends. You'll even be able to direct message people at the conference. So make sure you download that and give it a shot. So let's kick things off. I'm going to bring up Chaos CEO, Peter Mitev. Let's give him a big round of applause.
All right. Thank you, Lon. Hello, and welcome to Sofia, Bulgaria. Welcome to Total Chaos. I really enjoy that I see a full hall of crowd. This is the second year of Total Chaos, and I've been asked recently, why do we do this conference? How is it different? Well, we wanted a different kind of show. We wanted to bring artists, designers, and developers together and share their creative knowledge. Total Chaos represents the DNA of our company. It aligns passion, vision, and our technology and puts them together. Our passion comes from working with artists and their creative projects. Our vision to help visualize in the best possible way. And our technology, which always pushes the boundaries and drives the industry forward. But most of all, it's about all of us here celebrating our community, our creative community. You probably know that we've been quite busy last year. We managed to release our new platform, V-Ray Next, for almost all the 3D host applications that we support. And it's the fastest and smartest V-Ray version ever. Vlado will be talking more about that in details later. We introduced V-Ray into new platforms, where we brought our Academy-winning ray tracing technology into the real-time world. And you can learn about this later in our sessions. We brought V-Ray for Cinema 4D into the Chaos Group family. This year, we had the official release of Chaos Cloud, which is the easiest and fastest way to get your renders in the cloud. Only during the beta program, we managed to render 500,000 jobs and over 6 million frames. That's insane. And it's available at one click. Our Prague team managed to release 2 new versions of Corona for 3ds Max, where they really focused a lot on the faster interactive rendering, and Ondra from our Prague team will tell you more about it later. We also released Corona for Cinema 4D, which produces interactive rendering in Cinema 4D. And those of you who know Cinema 4D know what that means. It also supports the native Cinema 4D materials. We managed to release a bunch of improvements for Phoenix, where it is now faster and easier to use more than ever. We actually had a release this week. As you probably know, another thing that makes us really different is that we focus a lot on research and development. This is really important for us. What we call VR scans is a scanning technology where we manage to get real-time materials into CG in the most realistic way. We have partnered with material producers. We are currently delivering over 1,000 of scanned materials, and because of these relationships, we'll actually produce a lot more in the following year. Another very important part of our research and development is that it allows us to test new ideas, solve big problems, and improve your creative workflows. And because for us it's so important to continue our research and development. We organized a team to start working on real-time ray tracing. That's how we got to the point of delivering Project Lavina, which is still work in progress. And as we are very excited by real-time ray tracing, we managed to produce a tool that allows 300+ billion triangles to be ray traced in real time. And you can see more of that later. Research and development is important for us. That's why we gathered our Prague and Sofia teams to do first of a kind what we call Renderthon, where our creative developers bounce their heads around solving problems in your daily lives. And you'll be able to see the results of that in the near future. So all of these efforts throughout the years led us to the point of us officially launching a new initiative at Chaos called the Chaos Research. And I want to bring on stage the person who is going to drive that research, Jaroslav Křivánek.
Thank you so much, Peter. Good morning, everyone. This is a very exciting moment for me personally because I feel that with this initiative, with launching an academia, industry, computer graphics-oriented research lab in my hometown, Prague, I am accomplishing something that's been at the back of my mind for quite some time. And on the way of getting here, I have co-created a computer graphics research group at Charles University in Prague. I have helped with the development and commercialization of Corona Render, and then eventually we started working with Chaos Group. And all of these things are now somehow coming together into a joint initiative that's going to bear the name Chaos Research. Main ideas. We are not going to work for the next release of Corona or V-Ray. We are not even going to work for the release after that. We're looking 3-5 years down the line, and our aim is to really challenge and reinvent the admittedly somehow very clumsy ways in which computer graphics is being done today, to bring something really new on the table, something that will improve the workflow of the artists and help people focus on what's important, which is the creation. And in that respect, we hope that we will follow what happened with V-Ray when it was first released some 17 years ago, and hopefully also what Corona did 5 years ago, somehow changing to the better the way artists can work. We very much believe in sharing our ideas with the community. Many people out there do research that we read and put in our products. There's absolutely no reason for us to keep our ideas for ourselves. So you will see us at SIGGRAPH, you will see us speaking at the Rendering Symposium, you will see us speaking here at Total Chaos, and Ondřej Karlík later will have some specific invitations for talks. And third, we very much believe in a tight collaboration with academia. In fact, me personally, being one foot in the academia, another foot in the industry, I have witnessed the tremendous benefit that these two parties can actually have from working very closely together. I have seen students being super excited that finally someone is giving them projects that are useful, that someone will use to create something nice, something creative. And I have seen our products getting so much better thanks to the hard work that these students have done. So we will cherish this, let's say, synergy further on, and we will be tightly collaborating with the academic institutions, funding students locally at the local universities, but also across the globe. We will offer student internships, PhDs, and postdocs. So the reality is that, as Peter has mentioned already, we have been doing research throughout the years. And we have been following these ideas throughout the years. And you have seen actually some of our work being presented at conferences, and you have been able to use it in the products already for quite some time. So as an example, Asen Atanovsov and SIGGRAPH 2016 has presented his improvements to realistic procedural sparkles that you can use for your car paints. Last year at SIGGRAPH, we have presented our new machine learning-based solution for illumination rendering that is used in Corona, that is powering Corona. We have also presented at EGSR our new shot at what we called intelligent caustics, and you will definitely hear more about that throughout this conference. And we also focus on theory, on the real fundamentals. So I would like to draw your attention to the paper that's coming out at SIGGRAPH this year, where we are really re-evaluating the fundamentals of Monte Carlo sampling that's been presented more than 20 years ago by Eric Veach, and showing quite some improvements there. Okay, so this is what we have done so far, but where do we want to take it further? Of course, rendering is where we come from, and rendering is where we will keep going, and our driving vision in that direction is really push-button rendering, okay? So if there's anything technical in rendering, this is our problem, our job, not your job, the artists, okay? We will take care of that. And so no workarounds ever. That's what we want. But, okay, there's more to artistic creation than just rendering, and we are aware of that, and that's why we want to widen the range of ideas that we want to work on. And that will be in two specific directions. One is content and assets, and the second is support for individual artistic expression. So in this first direction, assets. Okay, so if you go to thispersondoesnotexist.com and you press reload, 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 you will be able to generate these super amazingly realistic images of people. And if machines can generate images of people that have never walked the planet Earth, well, they can probably also create images, create data, assets that are so hard to come by today, such as nice HDR sky maps. And turns out, indeed, yes, it is possible. We are very, very far from being able to call this a product, but we see that we can do this. And if this is possible for HDR sky maps, it's probably possible for many other assets too. So we see a way of completely changing the way we manage and obtain assets today. Second new direction that we would like to take is the idea of supporting individual artist expression. We can do super realistic renders today, but admittedly, at some point, you have seen enough of these, right? And you would like to be able to support something better, something that really bears your signature as an artist, such as the building, such as the drawing that you can see here. Turns out we can teach the computer to learn these artistic styles, and we can then use the computer to save the work on generating new variations or new views or even new designs with the same style, saving lots of the work. So with that, I would close up, and I would say if you have some cool ideas for what computer graphics should look like 5 or 10 years from now, if you have some ideas for what research we should be working on, or if you are the tech person that would like to help us with this happening, then come talk to me during the conference. I will be around. Thank you so much.
Thank you, Yarda. Next up, we've got Andra to tell you a little bit about what he's got going on in Corona 4.
Okay. I don't think, okay, now it's on. So thank you for coming and thank you for the introduction. And I will start this presentation with important fact, which is that Corona is actually 10 years old this year. So we are all celebrating, we have cakes, and this means I started this in 2009. It was originally a student's project, and the features were kind of limited back then. But we've came a long way, and this is us now. Now when you talk ArcViz, you really talk Corona, you talk V-Ray. And the industry as a whole did a huge leap forward from where it was 10 years ago. We now have physically based materials, physically based shading, just physically based everything. We have much better inputs. We can handle huge scenes. We have better post-processing, lens effects, and so on. And with all these advancements, just have to ask the question, like, is this it? Did we achieve the ultimate realism that we all seek? And the answer might surprise you. It's we didn't. And the reason is that the whole time we've been doing this, we've been silently ignoring one key aspect of light transport, and that's caustics. I'm of course talking about these focused tiny spots of light that are created everywhere in the reality by reflection and refraction. And if you remove them from the scene, you will it will just not look as realistic or as vivid. So with this in mind, the question is, why don't we compute the caustics? And the answer is simple. It was just too difficult to do until now. And it was too easy to just clamp them and remove them instead of computing it. So Corona was doing this, we were guilty, and most other renderers you've been using and most 3D images you saw in your life had missing caustics. So today, we want to change this. We are introducing one-click caustics in Corona as the next big thing in Corona and in rendering in general. So to achieve this, we tried several different algorithms, and we realized that none of them actually work in production. They don't fulfill the production needs. So we had to create our own algorithm, which is based on heavily modified vertex connection merging. And we will have a talk with details about this later in the conference. And as a result, this algorithm can really resolve any type of caustic generated by a reflection or a refraction. And also, very importantly, it can resolve indirect caustics, which are the ones that you see through some other reflection or through some glass. So to illustrate, this is an example from one different algorithm, previous work. And you can see inside of the glass, it's kind of noisy and it's dark. And if I go to the correct solution made by Corona, it's much better. So again, this is the dark and noisy bidirectional path tracing. And this is how Corona renders this scene. Of course, for this to be usable, it has to be compatible with all the features that we offer. So we just made it compatible with everything. For example, light mix. You can see in this video, we are editing the intensities of the lights in post-production, and the caustics react correctly. It's also compatible with ray switching, all the artistic control fakes, render elements, and basically everything that we offer. And another huge thing is the speed. So we worked really hard on minimizing the overhead. And as a result, you can take any scene, small or big, and you can render it with caustics. And you will pay some price for this. For example, in this image, it's about 80%, but it's still feasible to compute. Previously, it was maybe 10 times slower to compute with caustics. And also important thing is, whatever light setup you have in the scene, it will just work with the caustics. So you don't have to create some hidden invisible caustic slides or portals or includes. You just take your scene as it is, you click one checkbox, you wait a bit longer, and you get caustics and photorealistic result. So our ultimate goal is to make caustics just a mainstream effect that you use every day. Because when you think about this, going back to the 2009, back then, nobody was using, for example, subsurface scattering or physically based BRDFs in production. It was just some theoretical research stuff that you maybe used on special occasions, but you didn't daily. And even global illumination back then was sometimes just special effect that you wouldn't just automatically turn on. We want to do the same thing for caustics. We want 10 years from now for caustics to be as mainstream as we have global illumination today, because we need this to achieve the ultimate realism. So all of this will be available in Corona version 4. It will be released at the same time for both 3ds Max and Cinema plugin. The release will happen in next few weeks because we still need to tweak the algorithm, we need to fix some other bugs and so on. But if you want to try the caustics, we are doing a release candidate next week. So you can download it, you can play with it, and most importantly, you can tell us what you think and what are your experiences. Of course, the release will come with many other features, fixes, and optimizations. So I will quickly go through some of them for 3ds Max. So what we support now with Lightmix is you can render the scene once with multiple environment lights, and you can just switch between them in post-production in Lightmix, the same way as you would do with the scene lights. Okay, so you can see it here. Another improvement is in the interactive rendering and in our frame buffer. We made it better by allowing you to select objects directly in the frame buffer. So here's one perfect feature without video. So we improved the way we do volumetrics, and they now can be additively stacked. So for example, if we take this Disney scene with the huge cloud asset, we can place it multiple times in the scene, and when it intersects, it gets resolved correctly. We've also worked on our hair support. So for the Ornatrix plugin, we now support motion blur correctly.
I noticed.
We have one big production-oriented feature, which is called Select Map and Material. And it's a tool where you put in different variations of the look of your shaders. And you can then quickly and conveniently switch between them while you render. And finally, we've implemented fisheye projection for Corona camera. And this feature is special for us. It's because it has been actually developed by our Cinema 4D team. And it's because it was requested in the Cinema 4D plugin. And we want to make the effort to make the Cinema 4D team work more on the core features and influence the heading of the product as a whole. So that's why this time they actually did it. And in 3ds Max, we were actually the ones who took it from them. And finally, I have an update on our scattering tool, which was really revealed at the last Total Chaos. It's heading completion, and it's now in private beta version. It's focused on ease of use and on handling of large scenes. So we have a video prepared by our team, so let's just hope it will play. So you can see here that you can scatter anything from the smallest details, like the individual strands of cloth, up until like 1 kilometer square of forest. Okay, so this is everything from me. And if you are interested in the caustics and you want to learn how we achieved all of this, you can go visit our technical talk that Martin will be giving in the code track. It will be tomorrow at 4, and Martin will tell you what were the limitations of the previous solutions from the technical point of view and how we managed to fix them. Thank you.
Thanks, Ondřej. That was fantastic. Amazing stuff. As we switch over the slide deck here, I'm really excited to bring up our next guest speaker. For any of you that have ever used HDR images or image-based lighting in your workflow, which is probably all of you, I'm happy to introduce the father of image-based lighting, senior research scientist at Google Daydream, and Paul Debevec, who's going to talk about HDR, past, present, and future. Let's give him a big hand.
Thank you. Awesome. Thank you so much, Lon. It is an enormous honor to be here and get to talk a little bit about HDR. So let's see if we're able to advance the slides a little bit. My first interest in HDR actually wasn't for lighting. It was for motion blur. And when I was a high school yearbook photographer, one of the pictures I took kind of practicing for the portraits was lighting off fireworks in my backyard. And I noticed these great streaks you get if you take a long exposure photo, like for a second or so. And looking at these in the enlarger, I realized, since these are actually just tiny little points of light, that since this streak is about 100 times longer than it is wide on the negative, but it still hit white on the print, that means that the actual spark must have been at least 100 times brighter than what the film could actually record. And that was the first time that it kind of opened my eyes to the fact that the dynamic range of bright things in the scene can be hundreds or thousands of times brighter than what our cameras are actually recording. And it might be neat to get this. And you get cool photographic effects as a result. When I was a grad student at UC Berkeley, one of my colleagues was Brian Mertic doing dynamic simulation research. And this is some of the earliest stuff before you could do rigid body dynamics in Maya. He and John Canny were coming up with algorithms for this. And he got asked if he could feature his research on the cover of the UC Berkeley Engineering Summary. But the problem is, to put this on the cover of a book, how do you communicate the motion of what they were actually simulating in a still photo? So what I asked is if he could possibly render out a series of images, and then I would motion blur them together to help him make this cover. But I wanted to get some of those same bright streaks going across that I saw in the photography that I'd done. And so I had him render the diffuse and the specular separately, and I multiplied the specular pass by a factor of 10 before I averaged it all together. So I did the composite in high dynamic range, and that produced some images that had some satisfying streaks of light, or this glint of this coin as it flipped and caught the light going through. And another reason why it's good to have high dynamic range imagery, even if ultimately you're just going to produce a low dynamic range image for print. So the next thing that I realized is it would be really cool to be able to do this with real photographs. So instead of like rendering 2 passes for the different brightnesses that you've got, maybe you could shoot photographs at different exposures and then somehow come up with an algorithm that would take a series of exposures at different shutter speeds and put it together into an image that had floating point pixel values that covered the full range of the light in the scene. And so some work that I did with my PhD advisor, Jitendra Malik, produced these high dynamic range images where for the first time I was able to actually say that the pixel values were really proportional to the amount of light, and they wouldn't clip even if you looked directly into a window that had the sun behind it. And I wanted to show off what was useful about this, and the first thing I thought of was simulating motion blur. So in the SIGGRAPH 97 paper, our end result was taking a low dynamic range image, putting some motion blur on it, averaging between the pixels, and you can kind of see that the bright windows, are giving a little bit of a streak, but it's not that satisfying. If you use the high dynamic range values, put those through the blur filter, and then clip only at the very end, you get these nice satisfying streaks. And I knew that this was something that was potentially useful or even scientifically valid, because if you take a real photograph, actually moving the camera to produce real motion blur in a single exposure, which I did for validation, you actually get almost the same streaks as a result. And as it turns out, this actually was useful for visual effects and motion pictures. A couple of the students that I got to supervise at UC Berkeley went on to work on the Matrix films. And if you watch the Matrix movies, you might notice quite a number of high dynamic range blur streaks from HDR images they were taking, and then even doing some photogrammetry to project them onto backgrounds and getting these nice satisfying streaks. Now, another kind of photography that I was having fun with was shooting panoramas, and I really like shooting full 360-degree panoramas where you can see up and down and left and right and forward and back. And when I got to a project we were doing in the Rouen Cathedral for a SIGGRAPH art installation, I realized that the dynamic range in this scene also was pretty bright, so I actually bracketed the exposures and I shot the first 360 spherical image that actually had high dynamic range pixel values for that. And at some point it dawned on me that essentially what this is a record of not just what the scene looks like in high dynamic range, but what the lighting is like in the scene. For every direction we have unclipped linear response RGB pixel values telling how much red, green, and blue light is coming from any one of the directions. And the most natural thing I could think of is let's try to illuminate some computer-generated objects using these measurements of real light. And I was very lucky that I had access to ray tracing technology through Greg Ward and his radiance system he was developing at Lawrence Berkeley Laboratories. And with a bit of help from Greg, I was able to take some of these 360 HDR images, texture map them onto emissive surfaces surrounding objects, and then asking the ray tracer to simulate how that light would illuminate a computer-generated object sitting in that scene. And with that, I was able to work with some more UC Berkeley students and generate a couple of animations that showed CGI objects illuminated by measurements of real illumination with rendering with natural light, and then in a photogrammetric reconstruction of St. Peter's Basilica for Fiat Lux. And you can find those animations online if you're interested. This technique gets used in much more elaborate films, and it's become a relatively standard effect in the visual effects industry. So for example, in this scene done by Digital Domain, they had to put this CGI animated robot to look like he's actually in the scene with Hugh Jackman and shadow boxing with him. And so what they did is that after they shot the principal photography, they also shot an HDRI map, 360, and then used that with a ray tracing algorithm to illuminate that CGI character. And so it looks completely believable that he's actually really there in the scene and shadowboxing with Hugh Jackman at that point, which is what you need in order to tell the story. At this point I wondered, well, what if it wasn't just the robot that wasn't really in the scene, but what if Hugh Jackman couldn't make it that day? Or what if we actually wanted to shoot this scene in the studio instead of having to go on location? So where we could illuminate a real person with a 360-degree image of illumination that produces the lighting on them. And that was the idea behind the light stage devices that we built. So as soon as there were these RGB LEDs that were available, we were buying enough of them to basically create a surround 360 image that would illuminate people, and then light them with your HDRI map, and then if you composite them into the scene, then in theory it should look like that's the illumination that they would have had if they were actually there. We published this at SIGGRAPH 2002, and it took a while before it got picked up in a big way by the visual effects industry. There was a little bit of a use of this movie that we actually did in Light Stage 3 for the movie Social Network, but the film where this really took off, and something that we did a bunch of R&D tests with Framestore with, which is the film Gravity. And in this case, they actually had ray-traced environments that included the Earth and the space station. Even the astronaut suits were completely CGI, but then the faces of the actors were real and had to be integrated perfectly into these scenes. And so they actually used LED panels, not unlike what is actually behind me right now, to surround the actors and use light that was digitally computed in a ray tracing simulation to turn it back into real illumination to light the actor's face so it could then be redigitized by the camera and composited in with all the computer graphics rendering. And hopefully it looks like it all was part of the same scene and somebody's actually spinning out of control in space. Now, of course, the real world is actually a spectral renderer, and some of our latest work has been working on a light stage device that actually has red, green, and blue, but also amber, cyan, and white LEDs, and shooting our HDRI maps not just with mirror spheres, but also with color charts that have different spectral responses on all the squares, so we can figure out the spectral response of the illumination and then reproduce the light. The subjects on the left are actually really standing outside of our institute, and on the right, they're actually photographed inside the light stage and composited back into those scenes. And there's zero color correction that's being done. It actually just kind of comes out right. And it's pretty good at simulating daylight or fluorescent or tungsten and certainly LED illuminance for that. So we hope at some point people will start making LED panels that have a bit more than just red, green, and blue LEDs in them. At Google, one of the interesting applications that we're very interested in is actually in augmented reality. And I'm trying to go forward here. And in augmented reality, there's also a lighting problem as well. So you have your cell phone out, you want to put some CGI objects into this scene using AR, and you'd like them also to look like they were really there. And unfortunately, we won't have a visual effects department that can go out there with a mirror ball and an HDR camera in order to produce the lighting that you would need to light the object. But somehow you'd still want to be able to put a CGI object in there and have the lighting on it look relatively realistic. So what is something that we can potentially do for that? It's challenging because the cell phone camera isn't 360 degrees. It actually only sees about 7% of the scene. And it's not HDR. And even worse, it's not even really looking up where a lot of the light is coming from. So the hope is that somehow, just from that background plate, there's enough information from how other objects are being lit to figure out how our AR object should get illuminated. And in order to try to solve this, or at least have an approximate solution, we thought, let's capture a lot of training data that we can train a machine learning network to kind of figure out what the HDRI map should have been for that scene. So we actually built a little device that has 3 reflective spheres. These are designed with a mirror sphere, a diffuse sphere, and a matte silver sphere, so that one photograph in low dynamic range has enough information you can back out what the full HDRI environment would have been. And then we sent a few of these devices out in the world to capture millions of images of training data, showing what a background plate looks like and then what the corresponding spheres look like. And then from that, you can train a machine learning network that if it sees a new background plate without the spheres, it can regress through various networks and also through some GANs to figure out a possible version of what the HDRI map, what the light probe would have looked like for that. There's a paper on this topic that's going to be at CVPR 2019. And if we take a look at some results from this, you can see on the left, this is a little Android sculpture that's been put into the scene. You can see it's got reasonably plausible lighting. It adjusts to the camera's auto exposure. It's showing the learned HDRI map that's coming up there that wasn't actually recorded. And over here in this other example that was just shown at the Google I/O conference, the mannequin on the right is totally real. The mannequin on the left is added in augmented reality, and you can see that it's responding relatively realistically to the dynamic lighting. So that's what I have to say about HDRI maps. I'll be giving one more talk today at 6 o'clock in the art track, which is another project that we're working on at Google on light fields for virtual reality, 6 degree of freedom photographs you can actually move around in. And if you go around to that side of the conference room, there's a Vive set up, and you can put on a Vive headset and actually be inside some of the light fields today or tomorrow if you're interested. There's a bunch of collaborators I'd like to thank and a couple of websites you can check out here as well. And thanks very much for the opportunity to speak here at Total Chaos. Thank you. Thank you.
Thanks, Paul. That's really great stuff, as usual. Some just really impressive work. So as we switch the presentation back over, I'm going to bring up Vlado to tell you a little bit about what's on deck for the next versions of V-Ray. Let's welcome Vlado.
Hello. Hello. Right. So this is me. First of all, I'd like to thank everyone for coming to Total Chaos, both speakers and attendees. I'd like to thank everybody who made this conference possible. For the second time, you know, we did Total Chaos last year, and we didn't actually know how it was going to turn out. We hoped that it will be great, but we didn't know. But it turned out to be amazing. And this year, it's even better. We have some amazing speakers, and hopefully something for everybody to learn something new. My job here today is to tell you a little bit more about V-Ray and update you on where we are today. I have another talk coming up shortly after the keynote, where I'll be talking in more detail about V-Ray stuff. But just to give you a quick recap of where we are today, at the Total Chaos last year, we released V-Ray Next. And since then, we have officially released the next versions of the different integrations that we have. Most of them are already out there. And we also released a new version of the V-Ray benchmark. As usual, these integrations are not just about integrating the new V-Ray core itself, the new engine, but they also add significant workflow improvements for the specific application that they are targeted. So for example, for Maya, we had rewritten interactive rendering. For 3ds Max, we also had improvements in IPR. And Rhino and SketchUp have specific improvements in V-Ray that are targeted at managing scenes and assets, and so on. And we also released a new version of the V-Ray benchmark, which also is not just an update to the core engine, but it also uses a different way to measure the performance of machines. With our original version of the benchmark, we noticed people trying to benchmark machines with hundreds of CPU cores, and we found a better way to measure the performance of those machines for our V-Ray Next benchmark. We released an update of V-Ray Next for Maya actually just a few days ago, which has some improvements, specifically memory usage tracking, a feature that has been requested for a long time by our customers. We now support the AL surface shader in V-Ray GPU, which allows people to do realistic characters. Crypto maths turned out to be immensely popular with everyone, both in 3ds Max, Maya, but also other applications. And we made them work better with V-Ray proxy objects. And we also continued our work on improving the interactive performance of V-Ray. For 3ds Max itself, we'll have an update coming up in the next few days. After Total Chaos, it's almost done, but it needs a little bit of final polishing before it can be released. For that update, we are implementing some of the features that were originally done for Maya, like debug shading for IPR, the new tool material, but also new in this update is a bunch of improvements to the lighting algorithms in V-Ray for handling scenes with many thousands of light sources. We have done improvements to V-Ray GPU, and also the same memory usage tracking that we have in Maya will be available in 3ds Max as well. V-Ray for Houdini has been in beta for quite a while, since actually we announced the beta version at SIGGRAPH last year. And it has taken us a while to get to a release, but this is only because we wanted to make sure that V-Ray in Houdini supports everything that artists expect from it. And they can use all the workflows from Houdini that they are familiar with, and they can use V-Ray successfully to do look dev in Houdini so that they can match whatever they're getting in other applications that they're using, like 3ds Max or Maya. And specifically for Houdini, Ondřej, the main developer who works on it, figured out a way to render lots of instances very, very efficiently. And it's because Houdini is so very capable of generating complex geometry situations, we had to figure out a way to render those out. So we figured this way to recursively instance lots and lots of geometry. So the background for this slide that you're seeing here is actually has 1 billion dragon statues instanced, which you can, they're really small, so you can't really see them, but they are there. Yep, available soon, where soon is hopefully just a couple of weeks away. Here is a nice video that done with V-Ray for Houdini. Yep, that's the power of Houdini, which is famous for its dynamic simulation tools and V-Ray. Finally, a few words about V-Ray GPU. We are continuing work on it by adding more production features that people requested. With the new releases, besides the support for the AL surface shader, we've also added support for the V-Ray distance texture, the V-Ray curvature texture, and also deep outputs will hopefully be coming in the next update of V-Ray. Parallel to that, we are continuing our work on out-of-core rendering for GPU. It's yet another rewrite of the V-Ray GPU code, but it's been going on for a while, so hopefully we'll have something for people to use very soon. And we are working with NVIDIA to add RTX support to V-Ray GPU. And I would actually like to introduce Phil Miller, our VP of Product Management, to tell you more about what we are doing with GPUs.
Thank you.
Thanks, Vlado. So as Vlado mentioned, we're hard at work on taking advantage of the new ray tracing hardware that's part of the latest RTX cards that's coming from NVIDIA. we think that this holds a tremendous amount of potential for the rendering industry, and we're hard at work to make the most of it. So we've been in beta with RT Core support. Now this is in addition to the standard acceleration that you get on the GPU. So this is taking advantage of dedicated hardware that was made specifically for ray tracing. And we've been in beta now for this year with numerous artists using V-Ray GPU. And this portrait from Ian Spriggs is an example of what that beta can do today, running and taking advantage of the RT cores. Now, it's taking a bit of time for us to get this to you because we want to make sure that it's basically seamless, that you add an RTX card, and if it's there, we'll take advantage of it. So the next version that you get will simply run faster. Nothing for you to think about, no compromises across the board. So to get that all to work right, it's taking a little bit of time, and when you get it, you'll be happy. We'll be going into wider beta this summer for anybody with an RTX card that would like to try it. Now, the most common question we get is, well, how much speed up are we talking about? What type of a benefit am I going to get by having the new RTX cards? And the answer is kind of difficult to give because it really depends upon your scene. And more specifically, it depends upon how much shading is happening in your scene. Because the RT cores themselves are designed specifically for one part of the ray tracing process, and that's the ray casting. Shading is all on us, so it's all on the renderer, all happening in, well, basically standard CUDA for us. So as an example, on the left-hand side over here, we've got a standard scene. Almost 60% of it is happening in ray casting, but 41% is happening in shading. If we do an override material on that, then it goes way up, and then you have a production scene over here, and it goes way down again on the ray casting side. So the blue section that you're seeing there is the potential for what gets accelerated by these cores. Now, knowing this, we've been working towards this for over a year now. And knowing this, we decided, what would it be like if we designed a solution that was specifically aimed at that thing, that spent as much time ray casting and as little time shading as possible? And that led us to our Project Lavina. Now, Project Lavina is a research project basically to explore all the potentials of this RTX hardware. By designing a new solution that's expecting that hardware to be there. Now, Lavina means avalanche in Bulgarian, and we chose that term because we feel it has that much of a possible impact on the industry. So the goals of Lavina are to be real-time all the time, and to also do that while doing pure ray tracing, no rasterization. You might be seeing a lot of game engine taking advantage of RTX lately. Well, these are ray tracing effects. Most of the stuff going on there is still rasterization. You still have a game development workflow. We wanted to be pure ray tracing so everything could stay with the same workflow that you have with standard V-Ray. And also work with your original data. That whatever you have working in V-Ray can be brought into Lavina, and it will simply work and go real time. So by concentrating on this, we're actually seeing about a 5x speed up over what we would normally get from CUDA on the same GPU. So let's just see this in action. So today, Lavina is running in a standalone framework called a sandbox. And that framework is then accepting VR scenes being exported from any of our V-Ray products. Okay, so what you're seeing, like I said, is the VR scene output. All the animation, everything else. The camera navigation is all happening in real time. This is a real-time video capture. Now we're walking around a little bit, taking a look at it, and it's taking off again. But all of this is real-time ray tracing, no rasterization whatsoever, all happening at about 24 frames a second. This is another scene. This is an architectural scene. Taking a look. We're taking depth of field interactively. Navigating. We have a primitive UI to give us a little bit of control. One nice thing about ray tracing is that we don't have to worry about geometry, so all this is real geometry. Most of those trees are unique. We also get to use ray tracing for collision detection. So as we walk around, even up the stairs and everything, that's all handled automatically. Hiding and not hiding is immediate with this type of control. Where we come around and just, again, navigating, coming into the area. And all of this is just entirely real-time captured. Again, coming in, examining some objects, changing our minds, changing what the furniture looks like, and so on. And this is really just to explore what the editing routines would be like for you in your own creation application. So our goal with Lavina is to actually make it a render mode of V-Ray that would then be wherever you have V-Ray. But then we're also getting a lot of ideas for how people might use this separately as well. That one didn't really show off global illumination. I've got one final scene here that gives you a better hint of what we can do with GI. Again, all the effects that are possible with V-Ray, we can do to some extent within Lavina. There is no light baking happening in this example. This is all real-time global illumination happening with Lavina at about 25 frames a second. Again, no editing. We just take the scene directly as it was. In this case, it was from Max, bringing it over and running it there. So that gives you an idea where we're up to, a glimpse, and we hope to give you more glimpses later this summer. Thank you.
Just something a little different. So I thought now would be a really good time for us to talk about the last episode of Game of Thrones. So we're actually, it's a little bit bittersweet because we've been working with a lot of studios that have been involved with Game of Thrones since the very beginning. So this last episode coming up in a couple of days is bittersweet. The intro for Season 8, done by Elastic, was completely redone this year, as you probably noticed from the previous 7 seasons. Actually, the very first intro was their very first project done in V-Ray, which was kind of an exciting beginning to end. So we're doing a little work with them to capture that story. But it's also an example of what V-Ray Next can do. That was completely done in V-Ray Next for Maya. And we didn't get a chance to get the guys from Elastic to talk here because they were a little busy making sure everything's working for the final episode. But we are going to have them at Total Chaos Roadshow at SIGGRAPH. So that's right, we are taking Total Chaos on the road now, and we are spreading chaos wherever we go. Something else that we've been very excited to have been a part of for the last 10 years is the Marvel Cinematic Universe. And that's been in a variety of different ways, working with the visual effects studios that provide doing effects on everything from Endgame. No spoiler alerts here. I won't tell you anything about Endgame. As well as, I've got some clips here of Thanos from Infinity War. So if you haven't seen Infinity War, shame on you, because I don't know how you can survive to even look at social media these days without all the spoilers. But Digital Domain has done a really amazing job of bringing Josh Brolin's character to life as Thanos, and I wanted to give you a quick glimpse at the behind the scenes of how they did that.
The stone demands a sacrifice.
What?
You must lose that which you love.
Dread it. Run from it. Destiny arrives all the same. And now it's here. Or should I say, I am. Life is left unchecked. Life will cease to exist. I'm the only one who knows that. At least I'm the only one with the will to act on it.
Yeah, just some absolutely amazing work, and deservedly so. They won 2 VES awards for their work on Infinity War, and I'm sure they will be in the running again for Endgame. So if you get a chance, take a peek at Deke's talk. He's going to be giving a background on some of the things that DD has been working on the past couple of years. In a less destructive tone, but also in the Marvel Universe, I think some of you yesterday got to see Victor Hugo's masterclass, and Victor's an amazing artist. He's actually responsible, as you probably saw in the masterclass, for some of the first 3D covers of Marvel comics that have ever been produced. So you could take a peek at his talk later today if you want to learn more about that. Digital humans, like Thanos, have come a tremendously long way. Really happy to have Ian Spriggs back this year. Ian has actually done a couple of portraits since this one, but this is interesting because it's Scott Eaton, and Scott is actually also a speaker directly after Ian's presentation. So you could check out Ian's presentation later on today, and directly following it, Scott is going to be talking about his experiments with AI and anatomy. And directly following that, you'll have Paul Debevec, who just presented up here, is going to tell you a little bit about light fields. And they've actually taken Scott's likeness and turned that into one of the most realistic digital humans that you can ever experience in VR. Now, it's a little... if you do experience this, you can get right up close and personal with Scott, but please don't kiss his digital likeness. Just, you know. Really want to thank our platinum sponsor, Ubisoft. Without their help, we couldn't put on Total Chaos and give you the show that we want to give you. But I think their efforts and their contributions to the restoration of Notre Dame is also commendable. They're helping financially. They're donating over $500,000 to the restoration cause. They've also made Assassin's Creed Unity free for a period of time to let people experience the digital version of Notre Dame. And this, I think, is really exciting. They've actually offered to have let people have access to their CG assets if it will help in the restoration process. So let's give them a big hand for their help. Something else that you're seeing in the news quite a bit are design concepts that are coming through for what might become the Notre Dame of the future. And I'm really excited to see the chaos community joining in this conversation. This is a concept done by Belgian studio Mises, and it's been in all of the news networks. They're proposing a sort of Louvre-esque treatment of the roof of Notre Dame to pay homage to it, but maybe a possibility of what it could be in the future. So it's just great that this sort of discussion is happening, and there are teams that are contributing to it. I totally recommend you check out the animation. I think they just released an animation this morning that was on the news. Ubisoft is also going to be here talking about their world building and how they're using procedurally generated tools to create game worlds for Assassin's Creed Origins. And check out Javor's talk from Ubisoft Sofia. Also in the world building side, make sure you check out Sonia's talk about her experience working in blockbuster films at ILM and now as an environment artist for AAA games. So, continuing on that world building theme, we have the folks here from SlashCube, and they're showcasing their work that they've done with the architects SOM to imagine what it might be to have a village on the moon. Here's a quick peek. Maybe.
We choose to go to the moon in this decade and do the other things. Not because they are easy, but because they are hard. Because that goal will serve to organize and measure the best of our energies and skills. Because
We're also going to have an attempt at the show by our friends at Visual Vocal, who are AR and VR pioneers in the world of architecture and construction, specifically collaborative discussions. And they are going to try to set a record for the largest bring your own device collaborative session in architectural VR. So check out their talk tomorrow. Also, along the lines of what you can do now with artificial intelligence, you have to see Andrew's presentation from Promethean AI. Andrew stopped by our office not long ago to show us what he could build just by talking to his computer. And he literally, to create this scene, said, "Promethean, build me a bedroom for a 1980s movie fan." And it returned this. And it was amazing. And as I understand it, Andrew's also got some new tricks up his sleeve that he'd like to share at his talk. So be sure to see what he's got that's coming out that's new. So we talk a lot about visualization that we see in person, but how do you create visualization to train AI and machine learning? Or I like to call it how to train your robots. We're also going to have a code talk from Thomas about fractals in CG, both the history and where they can go, which is just fractals are beautiful to look at. A visualization and virtual reality session by our friends at Zaha Hadid. Andre Matos is back this year, who was a presenter last year, and he has been putting V-Ray GPU and VR scans to the absolute test. He's going to share some of the images that he created for the last launch of the Porsche 911 at the LA Auto Show. And the detail and resolution that Andre works at is absolutely astonishing. So please be sure to check out what he's got going on. Also along the lines, and maybe a little bit of a different take on some of the automotive stuff, check out Ioana's talk from Inc. And I love this. Who doesn't want to just make it look cool? So that's going to be a great one. Also, Ioana's going to be participating in our Women in Tech panel. And we have several panels that are going to be going on that we'll talk about in a second. Just love that. So this year we've added a bonus track. We've also got an education panel, some presentations from HDR Light Studio, i2Soft, and others. I really love to give a shout out to Alex Maltsev. Is he here? That's the artist who created all of this amazing artwork. Let's give him a big round of applause. It wouldn't look nearly as cool without you, so thank you. I mentioned the app earlier. This is a quick little layout of where we are in the building. Once we're out of here, so as soon as we're done with this talk, we're going to everybody scoot out of here and go get some coffee. We're going to split this into 3 rooms, and we're going to have the art, craft, and code rooms set up, as well as the discover and discuss area and the demo area where you can see on the 2 sides of the building. Coffee and lunch is on downstairs. If you'd like to win one of these super cool t-shirts,